Let's now have a look at equations that have a single logarithm. If an equation has one logarithm, then convert the equation to exponential form to solve for the variable x. So if we have a log of base b of x is equal to y, we convert this to exponential form by taking our base b, raising it to the power of y, and setting that equal to the argument x. And now this allows us to solve for x. So let's walk through an example together. Let's say you're asked to solve for x and check the answer. And we have a log of base 2 of x minus 3 is equal to 5. How would we go about solving for x here? Step 1, convert the function to exponential form. So we have our base 2, raise it to a power of 5, and set that equal to the argument x minus 3. And now we can solve for x. 2 to a power of 5 is equal to 32. And now we can add 3 to both sides, showing us x is equal to 32 plus 3, which is 35. And now that we've solved for x, step 3, we can check the answer by plugging x is equal to 35 into the original equation here for x. So when we plug in 35 for x, we get a log of base 2 of 35 minus 3, and 35 minus 3 is equal to 32, giving us a log of base 2 of 32 is equal to 5. How do we confirm this? We want to convert this to exponential form to make sure that this statement is true. So we take 2, raise it to a power of 5, and set that equal to 32. And 2 raised to a power of 5 is 32, confirming that this is the correct value for x, which is 35. So that is how we go about solving logarithmic equations that have one log in the equation. Let's now have you try a few practice questions. Solve for x and check the answer. Question number 1. A log of base 2 of negative 3x plus 5 is equal to 7. Question number 2. A log of base 4 of 2x minus 2 is equal to 3. And question number 3. A log of base 2 of x is equal to 3 minus a log of base 2 of x minus 2. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We are given the log of base 2 of negative 3x plus 5 is equal to 7. Step 1, convert the function to exponential form. So we'll take our base 2, raise it to a power of 7, and set that equal to the argument negative 3x plus 5. And now with this equation, we can solve for x. 2 raised to a power of 7 is equivalent to 128. And now we can solve for x by first subtracting 5 from both sides, giving us 128 minus 5, which is 123 on the left side. And that's equal to negative 3x. And we remove the coefficient negative 3 by dividing both sides by negative 3. So we find that x is equal to 123 divided by negative 3, which is negative 41. And now that we solve for x, we can check the answer by plugging x is equal to negative 41 into the original equation here for x. And when we do so, we get an argument that is negative 3 times negative 41, which is 123. And 123 plus 5 is equal to 128, giving us the statement a log of base 2 of 128 is equal to 7. So how do we confirm that this statement is true? We want to take our base 2, raise it to a power of 7, and set that equal to the argument 128. And 2 raised to a power of 7 is 128, confirming that this was the correct value for x, which is negative 41. So that is the answer to question number 1. Let's now have a look at question number 2. We have the log of base 4 of 2x minus 2 is equal to 3. Step 1, convert the function to exponential form. So we take our base 4, raise it to a power of 3, and set that equal to the argument 2x minus 2. And now we can solve for x. 4 to a power of 3 is equal to 64. And now we want to add 2 to both sides, giving us 64 plus 2, which is 66 on the left side. And that's equal to 2x. And we negate this coefficient of 2 by dividing both sides by 2. So we find that x is equal to 66 divided by 2, which is 33. And now that we've solved for x, step 3, we want to check the answer by plugging it into the original equation for x here. When we do so, our argument becomes 2 times 33, which is 66, and 66 minus 2 is 64, giving us the statement a log of base 4 of 64 is equal to 3. So how do we confirm that this statement is true? By converting it to exponential form. So we take our base of 4, raise it to a power of 3, and set that equal to the argument 64. And 4 to a power of 3 is 64, giving us 64 is equal to 64, which confirms that x is equal to 33. So that is the answer to question number 2. Let's now have a look at question number 3. We are given a log of base 2 of x is equal to 3 minus the log of base 2 of x minus 2. Step 1, we want to move the logarithms to one side of the equation. So we'll begin by adding a log of base 2 of x minus 2 to both sides, giving us a log of base 2 of x plus the log of base 2 of x minus 2 is equal to 3. And now on the left side here, we are adding two logs together. So we can combine the logarithms by multiplying the arguments. We're using the product rule. So we multiply x times x minus 2. And when we distribute this x, we get x times x, which is x squared. And x times negative 2 is negative 2x. So we get a log of base 2 of x squared minus 2x is equal to 3. And now we can proceed the way we were before. So step 3, we can convert the function to exponential form. So we take our base 2, raise it to a power of 3, and set that equal to the argument x squared minus 2x. And now we can solve for x. 2 raised to a power of 3 is equal to 8. And now if we subtract 8 from both sides, 8 minus 8 is 0. And that's equal to x squared minus 2x minus 8. And now we can factor this polynomial to find two possible values for x. So we have x squared minus 2x minus 8 is equal to 0. So we want to find two factors that have a product of negative 8 and a sum of negative 2. That would be negative 4 and positive 2. So we get x minus 4 times x plus 2 is equal to 0. And now we set each factor equal to 0 to solve for x. So when we set the first factor equal to 0, we get x minus 4 is equal to 0. And now we add 4 to both sides, showing us x is equal to 0 plus 4, which is 4. So x is equal to 4 is one possible value for x. So we find the second possible value by setting the second factor, x plus 2, equal to 0. And now we solve for x by subtracting 2 from both sides, showing us x is equal to 0 minus 2, which is negative 2. So we have two possible values for x, negative 2 and positive 4. So step 5, we check the answers by plugging each number into the original equation. So we'll start by testing negative 2. And when we plug negative 2 in for x here and here, that gives us a log of base 2 of negative 2. And this argument is negative, which is undefined. So that there lets us know that x is equal to negative 2 is not a value for x. This term over here, we have negative 2 minus 2, which would be negative 4. So this term would be undefined as well. So we find that x does not equal negative 2. So now we'll test positive 4, giving us a log of base 2 of 4 is equal to 3 minus a log of base 2 of 4 minus 2, which is 2. And if we add a log of base 2 of 2 to both sides to bring this log to the left side, we would get a log of base 2 of 4 plus a log of base 2 of 2 is equal to 3. And we can use the product rule to combine these terms by multiplying 4 times 2 to give us a new argument of 8. So we get a log of base 2 of 8 is equal to 3. And we want to convert this to exponential form by taking our base of 2, raising it to a power of 3, and setting that equal to the argument 8. And 2 to a power of 3 is equal to 8, giving us 8 is equal to 8, confirming that x does equal positive 4.